Just kind of a recap, guys. On Friday, we talked about different, we started talking about the properties, physical versus chemical. Physical, are they all the same type of physical properties? How can we measure? Let's go there first. That should be my first question. How do we know or measure physical properties? Yeah, it's using your senses. So we observe them using our senses. So what are some examples of physical properties? What's that? Visual, right? So what were some examples? So we kind of broke it down into two categories. What were the two categories of physical properties? Extensive and intensive. All right, let's start with intensive. Intensive are what? Doesn't depend on how much material you have. So they're kind of inside. They're kind of inside the substance, no matter how much you have. So what's an example of an intensive property that doesn't change? Color, density. That's the big one, guys. If I can drive that home, density is the one you want to remember because it's intensive. It doesn't change. All right. So then we have extensive. So intensive is kind of inside, and it doesn't depend on how much substance we have. Extensive then will depend. It's kind of outside. It does depend on how much you have. So examples of that would be what? Shout them out. Volume, mass, energy, okay? Those types of things. Then we have chemical properties. Chemical are kind of the ability to undergo a change. So these are things like flammability, reactivity, oxidation, all those types of things. So now we're going to take it a step further, guys. We talked about the properties. Let's talk about those changes. So matter is always changing. Like if you think about it, ice will melt in your drink, wood burns in your fire. All right. So we've got a physical change. Who can tell me what a physical change is, or like how would you describe a physical versus a chemical change? Any ideas? Yeah. Which would it be?
Well, you just said chemical.
I did say, yeah, kind of give it away. Why would it be a chemical? Why would an apple rotting be a chemical change versus a physical change? Say it louder, Laura. It's breaking down. Jonah, what did you say? It's not the same. That's exactly the right idea, guys. You want to think about it. Physical changes will be the same substance. They just kind of change the way that that you look at them. So, my fancy technology, I figured I'd type it in, but the problem with it is, now I just erase it. So there you go. Now you guys can read it. You don't have to deal with my handwriting. Does not alter the chemical properties of a substance. So an example would be cutting paper, or a phase change. When it goes from melting, or when you melt ice, so it goes from solid to liquid, it's still H2O. It changes in size or shape, but it's the same composition. When it comes to physical changes, the way I like to get my students to think about it, guys, would it be the same, or can you get it back to its original state fairly easily? So if I were to rip a sheet of paper, have I changed the composition? No, I've changed the size. We could kind of get it back, together. We could tape it, right? But it's pretty much, it's the same thing. It's just a different shape, okay? Again, ice melting, the picture that's in there, in your notes, you go from cubed ice down to liquid water. It's still H2O regardless, all right? Just where the particles are and how close they are has changed. Should be pretty easy. Can I go on to the next slide? All right, so if a physical change doesn't change the composition, what's a chemical change going to do? Yeah, it's going to change that composition. Okay? Oops, wrong. So, it's the composition of a substance is changed. So, rusting, for example. Now, any idea as to what might be one chemical sign? Like if you see something happen, that you can know that a chemical reaction is taking place, that a change in composition has happened. Any idea? What are some things that, from your experience, that you've seen could indicate a chemical reaction has taken place? Fire. Okay, so what about fire? Now, what does that temperature change? Absolutely. So heat's involved. Now I got to think, which line is that? Nope. Oh, well, there's that change going on too. There's a color change, right? Now, this isn't always going to take place with every single chemical reaction, but it's there a lot of times as a color change. So if you think about a fire, yeah, you've got lots of different colors associated with it, depending on what's happening to the composition. like we said, I gave it away. Heat or energy, guys, is being consumed. Bubbling. That's another example. And we're going to add in a fourth one that we will see throughout the school or throughout the year in lab. All right, number 4. We put it right below. And that's called a precipitate. Anybody know what a precipitate is? Biggest thing to think about. A car rusting. This time of year, I don't know if you guys have noticed, leaf colors are changing. So, filtration is our first one. I wanted my eraser. It's a physical separation. Okay, it's a physical separation. So, description, guys, you've done this. All right, you can describe it however you want to. You don't have to write all of it in there, but that's kind of the official definition. The filtrate flows through filter paper. Undissolved particles or solids remain on the filter paper. Okay, you can put in there whatever you need to help you remember it. Now, this last column, what types of matter will it separate? It's talking about, think about what are our 4 types of matter that we discussed on Friday in our flow chart. We had, all right, so pure, now how many pure substances do we have?
Elements and compounds. Right,
so there could be one type of matter is going to be an element, another one can be a compound. What are the other 2 types that we talked about? Somebody else. Somebody from that right side of the room that's been very quiet today. One of you 7 over there. I'll call names if I need to. I know them now. Look back in your notes. That's why we take them. So we've already talked about element, compound. What are the other 2 things we talked about? You got a whole flow chart. Should be easy. Sam, give me one. Heterogeneous mixture. The other one on the flip side would be homogeneous mixture. Good. So what are we going to separate here in terms of filtration? Is it the same throughout or is it different than what we're going to separate? Different, which means what? Heterogeneous mixture. Okay? Or mixtures, guys, that involve more than one phase. So sand and water. Okay? It's a mixture that has different phases. All right, now there's 2 different types of evaporations. We will do at least one of these. We'll use one of these at some point. It can either be using a watch glass or a crucible. Same idea. You're going to heat something up, and then it's going to leave something behind. So, this is a physical separation. We use these. Now, this is what you would typically use, like we were talking about with Kool-Aid, that it's a physical change. This is how you would get the soluble pieces, the sugar and the flavoring, back out of solution. We would evaporate the water off, and then what would be left behind is what was soluble. Okay? The dissolved solid would be left behind. Now, you are very limited on your precision here. Filtration, you can do it over and over again, and you can really separate things out. Here, it can be very limited, because how, do you know you've gotten it all? Maybe some of the particles will actually escape into the gas phase as well. So, you get a general idea, but you may not always recover what you put in. Filtration, you should be able to recover all of it. So, this is for homogeneous mixtures, is what you would use this for. Or a solution. Remember, that's another name for a homogeneous mixture. We have a whole unit later in the year about solutions, so we'll talk more about these terms like solute and solvent. If you're not familiar with them, you don't need to worry so much about them right now. Anybody ever heard this term before? Like a distillery? Or if you distill something, I'm sure you've probably heard of this. Right? This is how adult beverages are made. Okay, this is an interesting technique. So when I was in college, I actually had an internship and I worked at Kodak for a summer. And have you guys ever driven by Kodak? The Kodak plants in Greece? You see those two giant towers there? Those are like the smokestacks. Those are actually distillation towers. So as you go up higher and higher, they can actually control the temperature in each section. All right, so they'll get a huge crude vat of different solvents that are like wastes from other companies that they'll dispose of it, and Kodak will take it and they can actually separate it out and then use those solvents in their reactions. So they're recycling. They'll get the stuff for free and then they'll go ahead and use it and save a lot of money that way. So distillation, guys, is a physical means of separating things. It's definitely the most intense of the three that we've talked about so far. Okay? The difference between evaporation and distillation. Evaporation just lets the gas escape. Distillation will heat it up to the gas phase, but then it is all contained within a container, so then it recondenses it. All right, so it brings it back to the liquid phase. So you don't lose anything, which is why this is much more, it's got a higher recovery than the evaporation. Chromatography. Has anybody ever heard of chromatography before? Okay. There's a lot of different methods for chromatography. The picture, the one that's shown here in your picture is called paper chromatography. Again, you guys will do this at some point this year. But we'll talk a lot about different chromatography methods. This is, again, a physical one. So all these methods, guys, we've talked about and that we're going to use throughout the year, they're physical separations. Chemical are other ones that we'll talk more about in just a second. How chromatography works is separating them based on their size, solubility, as well as polarity. So we're going to add that in there too. And this is used for homogeneous mixtures, again, solution. Chemical separations, they require where you react a sample with something else in order to completely change it into a different compound. So when we do any type of reaction, that's that like chemical separation that we're going to talk about. And you guys will get a chance to do those at some point this year.